lesson. Financial models. Compound interest is the eighth wonder of the world. He who understands it earns it. He who doesn't pays it. Albert Einstein. Periodic compounded interest formula. A equals P times the quantity 1 plus R over N raised to the N times T. The amount A after T years due to a principal P invested at an annual interest rate R compounded N times per year. A is the total amount at the end of T years, the future value. P is our principal, the total amount that we borrow, whether by an individual from a bank in the form of a loan, or by a bank from an individual in the form of a savings account. It's our present value. R is our rate, the interest expressed as a percent, a charge for the use of the principal for a given period of time, usually on a yearly basis. And N is our number of compoundings per year. When we compound annually, N is equal to 1. When we compound semi-annually, N is equal to 2. Quarterly, N is equal to 4. Monthly, N is equal to 12. Daily, N is equal to 365. Finally, we have T, which is the number of years the amount P is borrowed. Applications. Question 1. Suppose that $100,000 is invested at a rate of 6.5% interest, compounded semi-annually. So, A, find a function that represents the final amount of the investment after T years. Let's write out the periodic compounded interest formula from the previous slide. In our question, P, or the principal, is $100,000 because it is our initial amount that is invested. R is equal to 6.5. The question says at 6.5% interest. We can rewrite that as a decimal of 0.065. N is equal to 2 because it is compounded semi-annually, or twice per year. Finally, T is equal to T. We're looking to find it, so we take a variable to represent it. We substitute our principal, so we have 100,000 times the quantity 1 plus substitution of the rate 0.065 over 2, the number of compoundings per year. Everything is raised to the power 2 times T. Thus, A of T is equal to 100,000 times 1.0325 raised to the power 2t. This is our function, and we can move on to part B, where it asks us to find the amount of money in the account after 8 years. So in this case, our time is given to us. The money is invested for 8 years, so our time is equal to 8. Substitute t by 8. A of 8 is 100,000 times 1.0325 raised to the power 2 times 8, which is equal to 16. Plugging that into a calculator, you obtain the value 100 $166,817.25.3. So in 8 years, that'll be the amount of money in our account. Question 2. A zero coupon, non-interest bearing bond can be redeemed in 10 years for $1,000. How much should you be willing to pay for it if you want a return of 8% compounded monthly? So the first thing we're going to do is write out the periodic compounded interest formula, just like we did in question 1. Now, A is $1,000 because this zero coupon bond can be redeemed for $1,000 at the end of the 10-year period. So that's our final value. Our principal is unknown. How much should you be willing to pay for it indicates that we are unsure of the initial value that we would pay for such a bond, and it is a variable we are solving for. Our rate is 8% because the question states you want a return of 8%, or 0.08 when written as a decimal. Now, n is equal to 12 because we wish for our bond to give the return compounded monthly. There are 12 months in a year, 12 moments of compounding, n is equal to 12. Finally, t is 10 years because this bond can be redeemed in 10 years. The periodic compounded interest formula is an equation with 5 variables: A, P, R, N, and T. We know 4 of the variables and we must solve for the 5th variable, namely P. It is known that A to the m times A to the negative m equals A to the 0, which equals 1. So to isolate the variable P, we must multiply both sides of the equation by the quantity 1 plus r over n raised to the power negative nt. Thus, P equals A times 1 plus r over n, everything raised to the power negative nt. We substitute the total amount redeemed, 1,000, times the quantity 1 plus the rate, 0.08, divided by the number of compoundings per year, 12, and then we substitute in negative nt by negative 120, because 12 times 10 is 120. Compute using a calculator, obtaining 450.52. Let's round to the nearest cent because we cannot pay in such a specific amount of dollars. So our final answer is you should invest $450.52 at a rate of 8% compounded monthly if you want to redeem $1,000 in 10 years. Question 3. What annual rate of interest compounded quarterly should you seek if you want to double your investment in 5 years? Our first step, as before, is to write the periodic compounded interest formula. The question states that we want to double our investment. It does not state a final price and a starting price. Thus, we can take our principal to be the variable P, and if we want to double our investment, A should be twice the value of P, written as 2 times P. The rate is unknown, that's part of the question. It's asking us what annual rate of interest we want. N is equal to 4 because of those keywords, compounded quarterly, 4 times a year, 4 quarters in a dollar. And 5 years is the term we're looking at, so T should be equal to 5. We have 4 of the 5 variables in our setup, so let's solve for R, dividing both sides of the equation by P and using the reflexive property of equations. Thus, the quantity 1 plus R over N raised to the power nt equals A divided by P. We substitute A and reduce the fraction to obtain 2. Then we can substitute the number of compoundings per year as 4, and then substitute the number of years by 5. 4 times 5 is 20, so we have 20 at our exponent. Now, the polynomial equation has 2 real roots, one positive and one negative. Since R represents a rate and it is positive, we can raise both sides of the equation to the power 1 over 20 without losing any solutions. So let's go ahead and do that. Thus, 1 plus R divided by 4 equals 2 raised to the power 1 over 20. Multiply both sides of the equation by 4, equivalent to 4 plus R equals 4 times 2 raised to the power 1 over 20. Subtract both sides of the equation by 4, equivalent to rate equals 4 times 2 raised to the power 1 over 20 minus 4, and we compute using a calculator, obtaining an approximate value of R as 0.14106. Convert this into a percent. R is approximately 14.106%. So our final answer should be that we should seek an annual rate of approximately 14.106% compounded quarterly if we want to double our investment in 5 years. Now, we have a continuous compounding interest formula that differs from the previous formula we utilized and discussed. A equals P times e to the RT. The amount A after T years due to a principal P invested at an annual interest rate R compounded continuously. A represents our total amount, P represents our principal, R represents our rate, and T represents the number of years. If you recall the previous formula, 4 of the 5 variables are present. The only one missing is that number of compounding. But the title of this formula, by saying continuous, clues you into thinking, well, there aren't a number of times of compounding. Compounding is always happening in these types of questions. So let's see this in motion. Question 4. How long will it take for an investment to triple in value if it earns 5% compounded continuously? We write the continuous compounded interest formula. A equals P times e to the RT. A quick way just to remember in your head could be APERT. We know that our investment triples. Thus, we can set our final amount equal to 3 times the principal, where the principal is represented by the variable P, and the final amount is thus 3 times P. Our rate is equal to 5% because it earns 5%. or 0.05 when we write it in decimal form. Time is unknown. It's the question. How long will it take? This is an equation with 4 variables, and to solve for the variable t, we multiply both sides of the equation by 1 over p. Thus, e raised to the power rt equals a over p. Substitute in a and reduce the fraction to obtain e raised to the power rt equals 3. This is an exponential equation, and the natural log function is a 1-to-1 function. Thus, natural log of e raised to the power rt equals natural log of 3. The composition of a function and its inverse at an expression equals that expression. Natural log of e raised to the power rt equals rt. Thus, rt equals natural log of 3. To solve for t, multiply both sides of the equation by 1 over r. Thus, t equals 1 over r natural log of 3. Substitute r, which then equals 1 over 0.05 times natural log of 3. Amplify the fraction by 20, which equals 20 natural log of 3, and compute this using a calculator. Equals approximately 21.97. Round this to the nearest whole year and obtain the final answer. It'll take approximately 22 years for an investment to triple in value if it earns 5% continuously. Not bad if I say so myself. Question 5. The average annual cost of college was $25,143 in the 2008 and 2009 academic year. This was a 5.9% increase from the previous year. Part A. If the cost of college increases by 5.9% each year, what will be the average cost of college for the 2028-2029 academic year? The question is asking us what the average cost will be in the future. Thus, our amount is unknown. The principal is $25,143 because that was the average annual cost of college at the beginning of this question. The rate is 5.9% because the cost of college increases by 5.9% each year. We write that as 0.059. It is compounded annually. We know that because it says each year. So n should be equal to 1. And t is equal to 20 because we initially started in the 2008-2009 academic year and we terminate in the 2028-2029 academic year. Thus, there are 20 years that pass. Write the periodic compounded interest formula. A equals P times the quantity 1 plus R over N, everything raised to the power NT. Substitute all the given variables. So that's equal to 25,143 times the quantity 1 plus 0.059, everything raised to the 20. Then we add 1 and calculate the interest rate and compute using a calculator to obtain 79,129.113. Rounding to the nearest cent, we obtain the average cost will be $79,000 $129.11. Part B. College saving plans, such as a 529 plan, allow individuals to put money aside now to help pay for college later. If one such plan offers a rate of 4% compounded continuously, how much should be put in a college savings plan in 2010 to pay for 1 year of the cost of college for an incoming freshman in 2028? So, if we want to pay 1 year of the cost of college, we need a final amount to equal that average cost we calculated. So $79,129.11. Our rate is 4% because it is stated in the question, rate of 4%, or 0.04. Our time is 18. This is found because the question asks how much should be put in the plan in 2010 to pay in 2028. There are 18 years that they have to save up this money. Our principal is unknown because the question is asking for it. How much should we put in the college savings plan at the start to end up with that final amount? Write the continuous compounded interest formula where A is equal to the principal times e raised to the power RT. This is an equation with 4 variables, A, P, R, and T. And to solve for P, multiply both sides of the equation by e raised to the power negative RT. Thus, P equals A times e to the negative RT. Substitute A times substitute R and substitute T. Then we take this expression and compute it using a calculator. And first, round to the nearest cent before we write our answer. So, our final answer is $38,516.27 should be put in a college savings plan in 2010 to pay for 1 year of the college cost of $79,129.11 for the academic year 2028 to 2029. Question 6. True or false? If the inflation rate averages 3%, then in 2 years, $1,000 will purchase $940. The amount is $940 because we are saying it will reach that. The future. Our principal is $1,000 because it's what we start out with. We start out with those $1,000 before we enter our 2-year period. The rate is negative 3%. The inflation rate averages 3%. When currency becomes inflated, its value decreases. So an inflation rate is a negative rate. We can rewrite negative 3% as negative 0.03. N is equal to 1. And T is equal to 2 because we are looking for what happens after 2 years. Let's write the periodic compounded interest formula. Substitute A, 940, equals substitute P, 1,000, times 1 minus 0.03. Negative 0.03 is our R. And it was supposed to be over 1, but we don't even write that. Everything raised to R and T. 2 times 1, which is 2. Performing calculations, equivalent 940 equals 1,000 times 0.97 squared. And we can compute the right side using a calculator, equivalent to 940 equals 940.90, which is false. Those two numbers do not equal each other. Final answer, false. Question 7. Elia wants to open a money market account. He visits 3 banks to determine their money market rate. Bank A, B, and C offer 6% annual interest compounded daily, 6.02% interest compounded quarterly, and 5.98% interest compounded continuously, respectively. Which bank here is offering the best deal? Bank A. A equals P times the quantity 1 plus R over N times to the power NT. The rate is 0.06 because that's our annual interest. It's compounded daily. There are 365 days in a year, so our N is equal to 365. The time is 1. We're looking at 1 year. And thus we can begin solving. This equals principal times the quantity 1 plus 0.06 over 365 raised to the power 365, which is equal to 1.06183 times our principal. So we jot that down to our side. Bank A's amount is equal to 1.06183 times the principal. Moving on to Bank B, our rate this time is 0.062, but it's compounded quarterly, so N is 4. 4 quarters in a year. Time is the same, 1, because we're doing a comparison against the 3 banks. Keep that constant. Now, let's solve. P times the quantity 1 plus 0.0602 over 4, everything raised to the 4th power. That gets us a value of 1.06157p. So jot that down to Bank B. Amount is equal to 1.06157 times the principal. Finally, Bank C offers continuous compounding, so we have to use the continuous compounding formula, unlike the formula we used for the other two. APERT, amount equals principal times E raised to the power rate times time. Rate in this case is 0.0598. Time is 1. And we can begin solving. Equal to principal times e to the 0.0598, which equals 1.06162 times the principal. Now when we write those multipliers all down next to each other, we can see with some careful analysis that the bank with the highest multiplier is Bank A. Thus, Bank A is clearly offering us the best deal here, albeit very small. The correct answer is A, one only, Bank A. The end.